Let's have Theo1 go through the gate, through the hidden wall entrance. There's no one else here. And finally through the door into the den. And we get this message, you see Twinrova here. Player 2 is seeing player 1. And now if player 1 looks, you see Theo1 here. Player 1 can see player 2. Oh my gosh. What's up everybody? Welcome back to the Descent Devlog. In today's update, I'm excited to share that I've added peer-to-peer multiplayer to the Descent. Let's kick things off with the front end. Alright, so I'm here in the command line. I'm in a directory with the version v0.3.0 prototype release of Descent. And we want to kick off a peer-to-peer network. So we're going to do that with a bootstrap node. This bootstrap node is going to be the node that all other peers know in advance that they can connect to. And so with this, if I were to just run the Descent executable without having a bootstrap node, I'll show you the error that we will encounter. So we get our typical intro message, and we have a new message. We have a prompt that says, "In a fallen world of magic and mystery, every hero needs a name. What shall we call you?" Okay, so I'll put in my standard role-playing game username, Twinrova, hit enter, get this message connecting to the Descent network, and we crash, connection refused. There's no bootstrap node available to connect to in our peer-to-peer network. Now, in the future, we'll handle this more gracefully, but for now, if I call Descent and I add the word bootstrap as an argument, then we'll see a different startup sequence. When we enter our name, now we get the message launching new Descent network, launching the game. Okay, and we're in the game. We get our typical you step out into a snowy clearing in a dense forest message. So we're outside the stone gate, and we get this extra message, there's no one else here, which is cool. We kind of hinted at this in a message in the den in the last update, but now we've made this command explicit. There's a new command you can enter called look. When I hit look, really all it's doing is just reprinting. It's setting the scene again, but it's also looking in the current room to see if there are any other players connected in this room. Okay, so I guess I'm going to step through to the den. I'm going to step through the stone gate. We're now in the parlor. If you're not already familiar, in the parlor, if you enter wall, you'll step through a hidden entrance in the wall. We're now in a hallway. We're going to go through the door with a giant painted on it, and we're now in the den. Okay, and the den is a place that I imagined to be kind of like a player hangout. Notice in each of these rooms, every time we step into a room, we get the scene described to us, and we get this message, there's no one else here. Okay, so now with that, I'm going to bring up a second terminal. We'll snap this one over to the side. So this is Twinrova player 1 on the left. We'll open up a new terminal on the right. Okay, and let's launch Descent. We'll call this player Theo1, and we get the message connecting to the Descent network, connected, launching the game. Okay, so then the game has kicked off, and there's no one else here. We're in the snowy clearing outside of the gate. Okay, and Twinrova in the den, if he looks around, he still can't see anyone. But Theo1 is outside the gate, so let's have Theo1 go through the gate, through the hidden wall entrance. There's no one else here. And finally through the door into the den. And we get this message, you see Twinrova here. Player 2 is seeing player 1. And now if player 1 looks, you see Theo1 here. Player 1 can see player 2. Oh my gosh. So freaking exciting. Okay, and now, for instance, if Twinrova were to go back through the door into the hallway outside the den, there's no one else here. And from Theo1's point of view, if we look again, there's no one else here. They're now in different rooms. They can't see each other. Note that we don't have any kind of messaging like, Theowen has entered the room or Theowen has left the room. For now, it's just a really simple look command, and you do get the message on entering a room. So if we go back through the door, we can see Theowen in the den. So that's pretty cool. But that's 2 players to showcase the peer-to-peer capability, really. I'm going to open up a third terminal. So let's bring this over. Okay, so on the right side now, we're looking at a player 3. So let's run the descent. We'll call this character Zork. Connected to the network successfully. There's no one else here. Let's go all the way through our massive game world of 4 rooms to the den. And Zork can see Twinrova and Theowen. And Twinrova can see Theowen and Zork. Now the question is, did player 3, when player 3 connected to player 1, was player 1 able to update player 2 that a new player has entered the game? Let's see. If we look, player 2 can see Twinrova and Zork. So all of the players know about each other. And now, let's say if player 3 were to leave the game, so we'll exit, you'll see the typical outro followed by some error messaging related to multi-threading that you can ignore. And if player 1 now looks in the room, we can only see Theowen. We only see player 2. And similarly, on player 2, if we look again, we can only see Twinrova. So player 3 successfully exited the game. Now, the interesting thing about a peer-to-peer network is that we're not reliant on a server to play the game. And so I want to demonstrate this by reconnecting Zork to the game. Let's step Zork all the way through to the den. Okay, Zork can see Twinrova and Zork can see Theowen. Twinrova can see Theowen and Zork. And now I'm going to have the bootstrap node leave the game. So Twinrova just logged out. We get all of our error messaging. And now player 2 and player 3 are still playing the game without the bootstrap node. And this is because the bootstrap node's only purpose is to allow players to connect to the game. And in fact, any node can serve as a bootstrap node. If you were to hard code the networking address information of either player 2 or 3 as the bootstrap, another player could connect to the game through these nodes. But we can continue playing the game in player 2's and player 3's session. So now in player 2, if I look, I can see that Zork is here. Twinrova's gone. On player 3, I can look and see that Theowen is here. Player 2 and player 3 can continue playing the game, moving around, updating each other about their position without the need for a central game server. And this is exactly why I've gone with the title Descent, a play on decentralized. Because in this project, we're experimenting with a decentralized multi-user dungeon, which comes with pros and cons. It's going to be harder to establish trust between peer nodes with no centralized authority, but at the same time, you're not dependent on any central server to play the game. And we will definitely continue to explore these themes as we move further in development, but this is everything there is to see in the front end with the new peer-to-peer multiplayer update. Thanks for making it this far. Let's now jump into the back end. Okay, so the main.rs module is now clocking in at a whopping 928 lines of code. Quite a few comments in here, and it actually was as high as 1,200 at one point, and I've whittled it down with some functionalization. Let's start running through it now. We have a new set of network constants related to a bootstrap node so that we can have a hard-coded bootstrap node to connect to. If we look at our main function, we now have, which is the entry point of a Rust program, we now have our introduction and our outro at the beginning and end. In the middle, we are getting arguments from the command line, and if we pass in that bootstrap argument, we are firing off a bootstrap function. Otherwise, we're firing off a connect function. Okay, we have a player struct to represent the player. In the bootstrap function, if we're bootstrapping, if we're going to serve as the entry point to the game, then we're not going to try to reach out and connect to anyone else. We're going to set up our player. We're going to create this player's data structure. So this player's data structure is shared among threads, and it represents all the players that are currently connected to the game. So when we're bootstrapping a new Descent network, we're going to make this data structure. We're going to add ourselves to it. We're going to be the only player connected. And then we're going to spawn a node listener. This is a listener that listens for player connections, player updates. It listens for any messages moving from peer to peer. And note that there's one node listener for the bootstrap and for peers in the network. It doesn't matter, either role has the same node listener. So this helps to show how peer nodes could serve as the bootstrap node. And you could imagine maybe a central list of connected players that a new player could look at to pick someone, any node at random, to connect to try to enter a Descent network. Okay, so we spawn the node listener and then we start the game. So we have one thread that is processing incoming messages. We have one thread that is actually playing the game, and then shared between them is this player's vector of connected players, and this vector is updated by the node listener when new players connect or drop or their position updates, and then that information is read as we're playing the game to see where other players are located. Now in the connect function, we're actually reaching out to the bootstrap node and trying to connect. So we put together the bootstrap node's networking addresses based on a hard-coded value that you can go in and configure at the top of the file. We create a player to represent this node. We create a player to represent the bootstrap node, and now we actually reach out with this connection message. We write our player's information, and then we get back this stream of all of the players that are currently connected. And so we have to parse that, split it out, and we have to build our own players vector based on all of the players currently connected that is sent to us by the bootstrap node. Now note I have this read message from stream and write message to stream. These are helper functions that are defined further down the page, and this is the primary mechanism that I'm using to communicate between nodes. We have a TCP stream connection that we create, we write and read to before shutting down. You can see after we receive here it is, the list of connected players, we shut the stream down. And once we've parsed all of that information, we have our list of players. The new node can now spawn its own node listener so that it's a part of the peer-to-peer network and start the game. So here we have the node listener. So we are accepting incoming messages on a TCP listener. And each time we get a connection, we're spawning a thread to handle the connection. So we get the socket stream, we get a type of message, and then we're switching on the type of message. So we have a few different message types. We have connection. This is the case where a new player is trying to connect to a bootstrap node. So we are getting information from the new player. We're adding that new player to our shared vector. Here you can see we're building one large message, the list of connected players, from the list of all connected players, and then we're streaming that to the newly connected player. And then after giving the new player a list of all connected players, the next thing we do is we loop through all of the connected players and other than the new player, and we stream each of them an update that a new player has connected. So we send this new message, and then we write the new player's information. All of the connected nodes can now adopt the newly connected node into their player's vectors and start to process the new player. Okay, we have the update message, and this is when a player is sending you an updated location. We have the new message, which is when a newly connected player is, we're being notified that a new player has joined the network. So from here, in the connection message where we're writing new and all of the new player's information, this is actually where a node would receive it. So if we've received the new message, we know that the next 4 streams are going to be that new player's information. We can create a new player struct from that information and then add the player to our player's vector. And then in the update message, we read the player's name and their location, and we update in our player's vector. We find that player in the player's vector, and then we update that player's location. Now note that this highlights one of the big cons of a peer-to-peer network, in that we are implicitly trusting our peer to be fair about where they're moving to. So right now there's no sense of competition in the game, so it doesn't really matter if a player wants to teleport around from place to place, but you could hack the client and you could send an update message to all of the other players to say that you've teleported from, let's say, the snowy clearing to the den, and all of the other players would just blindly accept that. And so this concept of trust in peer-to-peer, this is actually exactly one of the things that I'm hoping to experiment with in this project, and how you can maintain or build trust within a peer-to-peer network of role players. Okay, we also have a drop message, and if we receive the drop message, we get the player's name and we drop them from our list. Here's another attack vector. You could spam every player that a different player has dropped to forcibly disconnect another player from the game. So this works if you trust all of your nodes, but it's exploitable. Similarly, we have a stop signal, which tells us to shut down our current thread. In a better setup, we'd verify that this message came from ourselves, but right now we're not, so someone else could spam stop messages all over the network and cause all of the nodes to go offline. But for a first iteration, this works. And yeah, if we receive a message that we don't understand, we've got some debugging information, we close the stream, and that is the node listener. And it's really cool because this function, this node listener, serves as both a bootstrap and just a peer, the same listener for every case, which I think is pretty cool. Okay, so after this we have some supporting functions. We have an update function that we call from inside the game loop to update other players when we move. And so notice that we are opening a stream, we're writing the update message, we're writing our name and our new location before shutting down. We have a logout function where we are, for every connected player and skipping ourselves, we are opening a stream, we're writing a message that we're dropping, and we're writing our name so they can remove our name from their player's vector, closing the stream. We also send ourself a message, so we write a message to ourselves to stop, to shut down the listener. And this is the area where I'm still getting error messages on exiting the game, exiting Descent, because I'm not quite joining my listener thread correctly here. But we'll work on that. It functions for now. We have a port generator, and this is not really necessary. This wouldn't be necessary if you were playing over the internet, but I'm testing this locally. All of my peer nodes are all just on localhost. So this is a helper function just to randomly designate ports for new players. And here's an address generating utility. And then here are the networking functions: read message from stream and write message to stream. And these are cool because they have these failure messages that will tell you that we failed to write a particular message to a particular person, and so that's useful for debugging. And this makes the rest of the code much smaller and easier to read. Imagine these stream writes and stream reads and flushes being all spread throughout all of our networking protocol logic. That would be a lot more code, so this being functionalized squishes that down. We have an append new line utility function to help with messaging. We want to have a new line added to a message because our stream reader is actually reading until a new line character. So this is useful. And that's it. That is all of the new networking code. If I scroll through what we have for printing to the screen, these are like command line utility functions. We have this new look function, right, that lets you look around, and what this is actually doing is it's getting a lock on the player's vector, the current state of the player's vector, and for every player that is in the same room as us, it prints that you see that person here, which is pretty straightforward. And then if we didn't find a player, we print that there's no one else here. These delays were already there. All of the game itself, we haven't added any rooms, or we've only barely changed the text. In the den, I had a message that was saying there's no one else here consistently to maybe hint at multiplayer coming soon. But so I removed that message because now with the look command, you'll actually see whether someone is there or not. So this is all the same. And now we have the very last thing is the game loop. And so now we've added this look statement. So after setting the scene, we have a delay, and then we run the look command to show who is in this room. And then if we go down to the non-exit actions, we have a new one called look, and it actually, it's funny, for now, the look command does nothing. It just restarts the loop, printing both the scene and the look statement. So yeah, that is it, and that's actually everything on the back end. We're clocking in at 928 lines of code, and we will optimize this further. We're going to break the game logic out of the engine. We're going to break this into modules, but for now, this is a multi-user dungeon that you can, at a minimum, step around through a world of connected rooms and see other players. And that is everything there is to know about the backend in the version 0.3.0 prototype update of the Descent. Thank you so very much for watching. If you enjoyed today's video, don't forget to hit that like button and to subscribe for more Descent content. Until next time, this is Christian, signing off.